Hello! In this video we're looking at section 9.5. We're solving quadratic equations using the quadratic formula. Let's take a look at our learning targets for this video. By the end of the video you will be able to use the quadratic formula to solve quadratic equations, and you will also be able to interpret what we call the discriminant. So let's look at what the quadratic formula is. The quadratic formula will help you find the real solutions of any quadratic equation that's in standard form when we look at our coefficients and we plug them into this formula here, we substitute them into this formula here, we will be able to find our x values or intercept values. So I encourage you to pause the video and write down this quadratic formula. And now that you've taken the time to write down the quadratic formula, let's take a look at a particular part of the quadratic formula. So if we look at this portion that's underneath our radical, right, as we can see down here, b squared minus 4ac, this portion of the quadratic formula is called the discriminant. And looking at the value for the discriminant, whether it's positive number, or if it's 0, or if it's negative, this will indicate the number of solutions that we have for our quadratic equation. So we'll look at this in a moment. I just wanted to point this out to you that this portion of the quadratic formula is called the discriminant. And we'll talk about that as we go through one of our examples. So let's take a look at some examples. Okay, so our first example, we're solving this quadratic 12x squared minus 4x minus 5 equals 0. Using our quadratic formula. So first thing we need to do is make sure that our quadratic is in standard form. Remember, standard form is ax squared plus bx plus c, and we're setting this equal to 0 to find the zeros of this quadratic. So we can see that this is in standard form. I'm going to go ahead then and label what I know to be a, b, and c. So a in this case is our leading coefficient, which is 12. B is our coefficient on our linear term, so this is a negative 4. C is the constant value that we can see, and make sure you take the sign with it. C is a negative 5. So now that I've labeled A, B, and C, I'm ready to use my formula. And our quadratic formula starts as x is equal to negative b plus or minus the square root of b squared minus 4ac over 2a. Okay, so we're going to plug in the values that we know. So we know a is 12, b is negative 4, and c is negative 5. So we have x is equal to a negative, and then we're plugging in our b value. So we know b is negative 4. Then plus or minus the square root, and we're taking b squared. So the value for b, and we're going to square it. We know b is negative 4. Then by the formula, we're subtracting 4 times our quantity for a, which is 12, and we're multiplying that to c, and c we know is negative 5. All of this is then over 2 times a, which is 12, okay? So now we're ready to simplify. So simplifying, we end up with x is equal to a negative times a negative is a positive, plus or minus the square root. So we have negative 4 squared, so that's going to give us a 16, so I'm just going to write that up here. This is 16, and we're subtracting 4 times 12 is 48, times a negative 5 gives us 240. So that's a negative 240. So really this is 16 minus a negative 240, so that's really 16 plus 240. Now you need to show all of this work, so I'm doing a little shortcut by simplifying what's underneath the radical. And if you remember this value under the radical, we call it the discriminant. So I'm just doing the discriminant work right here. But you need to show all of this work when you're solving your problems for your homework. So 16 plus 240 gives us 256. And all of this is going to be over 24. So if we look at the square root of 256, we can see that this is a positive number. So our discriminant is positive here. So we're going to end up with two solutions because this is positive. So 256 is a perfect square. The square root of 256 is 16. So this is 4 plus or minus 16 over 24. So you can see we're going to have two solutions. We're going to have one solution when we have a plus sign in the numerator, 4 plus 16 divided by 24. And then we're going to have another solution when we have a minus in our numerator, 4 minus 16 divided by 24. So let's simplify. 4 plus 16 is 20 divided by 24. Well, we can see that they have a common factor, which is 4. So when we divide that out, we're left with 5/6. And then here we have a negative 12 over 24. When we simplify that and divide the numerator and denominator by 12, we have negative 1/2. So you can see here are two x-intercepts. They're occurring at negative 1/2, 0, and 5/6, 0. Okay, we're taking a look at example 3, which matches up with example 3 in your textbook. And the directions are to determine the number of real solutions. So here we're not solving our quadratic, we're not using the quadratic formula in its entirety to find our x-intercepts. We just want to know how many real solutions are there. And when you're looking for the number of real solutions, all we need to look at is our discriminant. And remember, our discriminant is the portion that is underneath the radical, which is b squared minus 4ac. So let's look at this example here. Here's our quadratic, 2x squared minus 3x minus 1 equals 0. We can see that it's in standard form, so we're ready to label our a, b, and c. A is equal to 2, b is equal to negative 3. Make sure you take the sign with your coefficient, and c is equal to negative 1. Looking at our discriminant, we said it's b squared minus 4ac. So substituting in what we know, we have negative 3 squared minus 4 times a, which is 2, times c. Okay, continuing to simplify. Negative 3 squared gives us a 9. And then we have 4 times 2 times negative 1. So I'm going to ignore this sign for right now and multiply 4 times 2, and I get 8. 8 times a negative 1 gives me a negative 8. And if I have minus a negative 8, I'm really adding 8. So I have 9 plus 8. This simplifies to 17. And since 17 is a positive number, my discriminant is positive, I will have two real solutions. Okay, our next example, we're looking at x squared plus 4 equals x. As you notice, this is not in standard form, so that needs to be our first step. So we're going to move our linear term, our x term, over to the other side by subtracting x on both sides. And when we do that, we end up with x squared minus x plus 4 equals 0. Now we're ready to label. A is equal to 1, b is equal to negative 1, c is equal to positive 4. Using our formula for discriminant, we see negative 1b squared minus 4 times our a value, which is 1, times c, which is 4. Simplifying, we have 1, and 4 times 1 is 4. 4 times 4 is 16, so we're subtracting 16. So we can see that our discriminant ends up becoming negative 15. So since our discriminant is a negative number, we can see that there are no real solutions. All right, let's explore what we've looked at in this video. So we set our quadratic formula, which will work to solve any quadratic equation, is x is equal to negative b plus or minus the square root of b squared minus 4ac. All of this is divided by 2a. b squared minus 4ac, we said this portion of our quadratic formula is called the discriminant. And if we look specifically at the discriminant, we can identify how many solutions we will have for our quadratic equation. So let's look. If our discriminant ends up being a positive number, when our discriminant is positive, our quadratic formula simplifies to negative b plus or minus the square root of a positive number over 2a. So we can see that when we take the square root of a positive, this will be a real number, and we're adding or subtracting this value. So it will give us negative b plus this value divided by 2a and negative b minus this value divided by 2a. In this scenario, we will have two real solutions. When our discriminant is 0, we end up with negative b plus or minus the square root of 0 over 2a. Well, the square root of 0 is just 0, so we're adding or subtracting nothing. So our solution will just be negative b over 2a. So there's one real solution. And when our discriminant evaluates to a negative number, we end up with negative b plus or minus the square root of a negative number over 2a. So you know that the square root of a negative number is not a real solution. So we will end up with no real solutions when our discriminant is a negative number.